Right now, 4 billion miles from where you are sitting, a world that we stripped of its title and threw away like a receipt is running its own private chemistry lab. It has been running it for longer than complex life has existed on Earth. And it is producing the same class of organic molecules that scientists believe fell from our own sky before anything alive had ever drawn a breath on this planet. Nobody programmed it. Nobody designed it. The faint light of a distant sun hits frozen methane, and the methane breaks apart, and the broken pieces fall back down as something new, something heavier, something reddish-brown and sticky and eerily familiar to anyone who studies the origin of life. 4 billion years of that. Nonstop, on a world we decided was not interesting enough to even call a planet. But that is not the part that should keep you awake. And the part that should keep you awake is what the James Webb Space Telescope confirmed when it finally turned its infrared eye toward Pluto and read the chemistry directly. Because what came back did not match the models, it did not match the assumptions, and at least one part of it has never been observed anywhere else in the entire solar system. Stay with me, because by the time I am done, the frozen edge of our solar system is going to feel a lot less empty and a lot less dead than you have been told. Subscribe now if you want more stories like this one, because what is coming out of the outer solar system right now deserves a much bigger audience than it is getting. Let me take you back to where the story actually begins. February 1930, an observatory in Flagstaff, Arizona. A 24-year-old assistant named Clyde Tombaugh is sitting in front of a device called a blink comparator, flipping between two photographic plates of the same patch of sky taken on different nights, looking for a single point of light that moved. Most nights produced absolutely nothing. Then one evening, he found it. A dot had shifted position against a field of fixed stars. That dot became the 9th planet in our solar system, discovered by a Kansas farm boy with no college degree who got the job because he had mailed hand-drawn sketches of Jupiter and Saturn to the Lowell Observatory and impressed the director enough to hire him. For the next 75 years, Pluto existed mainly as a guess. It was too small and too far for any telescope on Earth to resolve into more than a tiny smudge of light. We knew it was cold. We knew it had a tilted, stretched orbit that swung it inside Neptune's path for 20 years at a time before flinging it back out past 4 billion miles from the sun. We knew almost nothing else. It sat on the wall chart at the back of every 5th grade classroom, a name and a circle and a question mark. Then in 2006, the International Astronomical Union held a vote and took the title away. Pluto became a dwarf planet, the only world in the recorded history of astronomy to be discovered, celebrated for 3/4 of a century, and then formally voted out of the category that made it famous. For most people, that was the end of the story. A small, frozen, irrelevant leftover from the formation of the solar system. That assumption did not survive its first encounter with actual data. In July of 2015, after 9.5 years of travel across 3 billion miles of empty space, NASA's New Horizons spacecraft shot past Pluto at more than 30,000 miles per hour. There was no orbit, no second pass. The probe had roughly 10 minutes of close approach to photograph and measure everything it could before continuing into the Kuiper Belt forever. What it sent back broke every expectation anyone had ever held about this world. A massive heart-shaped plane stretched across the surface, roughly 1,000 miles wide, pale and smooth and young looking against ancient cratered terrain on every side. Mountains built from water ice frozen so hard at those temperatures that it behaved closer to granite than anything you would recognize as ice, some of them rising over 11,000 feet into a thin, hazy sky. Fields of nitrogen ice appeared to be slowly churning in cell-shaped convection patterns, hinting at warmth and motion happening somewhere beneath a crust that every textbook had described as dead. And layer after layer of blue haze rose hundreds of miles above the surface, visible even when backlit by the distant sun. Pluto did not look like a frozen corpse. It looked like something that was still becoming. But New Horizons only got one look. It captured what it captured and kept flying. Whatever it missed during that single pass would remain unknown for years, while scientists picked through the data and argued about what it meant. What they needed was not a better photograph. They needed a way to read Pluto's chemistry from 1,000,000 miles away without ever sending another spacecraft. And that is exactly what the James Webb Space Telescope was built to do. Here is what makes Webb fundamentally different from a mission like New Horizons. Webb does not fly to a planet and snap a portrait. It reads light itself, splitting reflected and emitted photons into their individual wavelengths to reveal the exact chemical fingerprint of whatever it is pointed at. Aimed at a faint pinprick of sunlight bouncing off a world 4 billion miles away, it can identify specific molecules in the atmosphere, measure temperatures across different layers, and track how those conditions change over time, all without physically traveling anywhere. The technical challenge involved is worth sitting with for a moment. Pluto and its largest moon, Charon, orbit so close together that separating their individual thermal signals had been practically impossible with earlier telescopes. Researchers had tried for years to isolate Pluto's infrared signature from the bleed of Charon sitting right beside it, and had repeatedly come up empty. Webb's 21-foot gold-coated mirror and its mid-infrared instrument finally solved that problem, cleanly reading Pluto's own thermal output for the first time. Starting in late 2022, Webb turned that capability toward the Pluto system, and what has come back is not a prettier picture. It is closer to a full medical report on a patient nobody thought was alive. In 2017, a planetary scientist named Shi Zhang at the University of California, Santa Cruz proposed something that most of his colleagues considered unlikely. On Saturn's moon Titan, atmospheric haze traps heat, warming the surface below. Zhang argued that Pluto's haze was doing the exact opposite. He said the hydrocarbon particles suspended in that thin nitrogen atmosphere were absorbing the faint sunlight that reached them, and then radiating that captured energy straight back into space as infrared heat, faster than the atmosphere could hold on to it. The haze was not acting like a blanket, it was acting like a radiator. At the time, there was no instrument sensitive enough to test the idea. Zhang and his co-authors made a specific prediction in their 2017 paper. If the haze was cooling Pluto, there should be a measurable mid-infrared emission signature, and a sufficiently powerful telescope should be able to detect it. That telescope arrived on Christmas Day 2021 when Webb launched. An international team led by astronomer Tanguy Bertrand at the Paris Observatory used Webb's mid-infrared instrument to measure Pluto's atmosphere directly. Their results, published in the journal Nature Astronomy in June of 2025, confirmed almost exactly what Zhang had predicted 8 years earlier. Pluto's atmosphere is being actively cooled by the very haze particles floating inside it. The upper atmosphere turned out to be roughly 30 degrees Fahrenheit colder than earlier models had expected. Zhang himself said afterward that having his prediction confirmed was rare in planetary science. Researchers now describe what Pluto has as a genuinely new kind of climate, one that behaves differently from every other atmosphere studied anywhere else in the solar system. Pluto is not simply cold because it sits far from the sun. In a very real physical sense, Pluto is refrigerating itself. Now here's the part where this stops being a story about a distant frozen world and starts being a story that reaches back to you. Because the chemistry that Pluto is performing in its upper atmosphere is not alien. It is familiar. Those same haze particles, the tholins that coat Pluto's surface in reddish-brown organic sludge, belong to the same broad family of prebiotic molecules that scientists studying the origin of life on Earth believe reigned out of our own early atmosphere billions of years ago. The question of where Earth's first organic building blocks came from, whether they formed here on the young planet or arrived from space carried by comets and asteroids and slow chemical processes happening in distant icy environments, is one of the oldest open questions in biology. Pluto is running a live version of that chemistry right now. It has been running it for over 4 billion years. And unlike Earth, where that process finished playing out and left behind only indirect evidence buried in ancient rock, Pluto has the whole experiment still going. An active natural laboratory producing the raw ingredients of biology on a world too frozen for any of it to ever ignite into life. Studying that process does not just tell us about Pluto. It gives researchers something they cannot get any other way, a working model of the chemical conditions that may have existed before life began anywhere. But the chemistry gets stranger before it gets simpler, because Pluto is not keeping its atmosphere to itself. Methane and other light molecules drift upward through that thin nitrogen envelope, slip past Pluto's weak gravity, and escape into space. Scientists already suspected this was happening. What nobody could confirm until Webb was where all that escaping material was going. It was not vanishing into the void. Something was catching it. Charon. Pluto's largest moon, roughly 750 miles across, locked in such a tight gravitational embrace with the dwarf planet that the two worlds orbit a shared point in empty space between them, each one permanently showing the same face to the other. Most of Charon's surface is unremarkable water ice, ancient and heavily cratered, except at the poles. Both poles are stained a deep, unmistakable reddish-brown, darker than anything else visible on the moon. For years, researchers had a hunch about where that color came from, but no way to prove it. The mechanism turns out to be tied to Charon's extreme seasons. Because of the way the system is tilted, Charon's polar regions spend multiple decades at a time in complete darkness, with no sunlight reaching them at all. That darkness turns each pole into a cold trap. Methane molecules escaping from Pluto's atmosphere drift across the roughly 12,000 miles separating the two worlds, get pulled in by Charon's gravity, and freeze solid onto those dark polar surfaces simply because there is no warmth to keep them as gas. When sunlight eventually returns decades later, it does not melt the frozen methane away. Ultraviolet radiation and cosmic rays break the frozen molecules apart and reassemble the fragments into heavier, more complex, reddish compounds, permanently locking in that dark stain rather than letting it evaporate back into space. Two worlds locked together in a slow, ongoing exchange of atmosphere and color that has apparently been happening since long before either one had a name. If you are the kind of person who stays for the science instead of skipping to the next video, go ahead and drop a like right now, because it genuinely helps this kind of content reach more people who would want to hear it. And Charon had one more surprise. In October of 2024, a team led by Silvia Protopapa at the Southwest Research Institute used Webb's near-infrared spectrograph to take a closer chemical look at Charon's surface. Their results, published in Nature Communications, confirmed the presence of two compounds that had never been detected there before. Carbon dioxide, the same gas you exhale with every breath, and hydrogen peroxide, the same compound you would pour on a cut to disinfect it, both sitting frozen on a moon billions of miles from Earth. The carbon dioxide most likely came from deep underground, primordial material from the disk of gas and dust that formed the Pluto system itself, exposed to the surface when impacts punched through the ice. The hydrogen peroxide formed right there on the surface, produced by years of ultraviolet radiation and solar wind particles striking Charon's water ice and rearranging its molecular structure into something new. Protopapa said the hydrogen peroxide detection was unexpected. She had not anticipated finding evidence of it. The picture that emerges from all of this is not what anyone imagined 20 years ago. A bleeding planet slowly feeding its stolen breath to a poisoned moon, both of them wrapped in chemistry that has no equivalent anywhere else in the solar system that we have studied. Now picture what it would actually be like to stand there, because the numbers alone do not communicate what Pluto really is. Sunlight reaching that surface is roughly 1,000 times dimmer than sunlight on Earth. High noon on Pluto is darker than the heaviest overcast evening you have ever stood in. The sun is still visible, but only as an intensely bright point, smaller than a pinhead held at arm's length, giving off no real warmth and no glare. You could stare directly at it without flinching. The sky around it would settle into a permanent grayish-blue twilight, thick with haze, never fully day, never fully night, just an unchanging dim glow that never lifts and never deepens. The ground beneath your feet would not behave like any ice you have ever touched. At nearly 400 degrees below 0 Fahrenheit, water ice is not slippery. It is stone. It rings like metal when struck. You could take a sledgehammer to it and bounce off. The atmosphere is roughly 100,000 times thinner than Earth's. There is essentially nothing to breathe, but that would be the second thing that killed you. The first would be the cold. Exposed skin would freeze faster than your nerves could register pain. Your tears would crystallize before they fell, and then it would snow on you. Not water snow, nitrogen snow. The same nitrogen that makes up 78% of the air you are breathing right now, drifting down from the sky and settling on your frozen face as fine white powder. Overhead, Charon would hang in the sky and never move. Always the same spot, always the same face turned toward you, frozen in place like something watching. The surface holds more. East of that famous heart, in a region called Tartarus Dorsa, New Horizons photographed something no spacecraft had documented anywhere else: a field of towering ice blades, rows of jagged spires made of frozen methane, some reaching over 1,500 feet tall, lined up in nearly parallel ridges with gaps of a few miles between them. On Earth, similar formations called penitentes form in high-altitude deserts and rarely grow taller than a person. On Pluto, the same basic erosion process driven by the sublimation of methane ice under faint sunlight over tens of millions of years has produced structures dozens of times larger. A study published in 2025 using New Horizons data suggests these blades may wrap around roughly 60% of Pluto's equator, an entire ring of frozen knives circling the dwarf planet. And then there are the mountains that nobody can fully explain. South of the heart, two enormous isolated peaks rise out of the surrounding landscape. Wright Mons stands roughly 13,000 feet tall with a base about 100 miles wide. Picard Mons rises even higher, possibly close to 20,000 feet, with a footprint wide enough to rival Mauna Loa, the largest active volcano on Earth. Both peaks have deep central depressions at the summit, ringed by concentric fractures and lumpy, uneven flanks that look exactly like cooled lava flows, except there is no lava on Pluto. If these are what they appear to be, they are cryovolcanoes, structures that once erupted not with melted rock, but with a thick slurry of water, ammonia, and methane forced upward from somewhere deep beneath the icy crust. The implication either way is the same. Something at some point in Pluto's relatively recent geological history was warm enough beneath that frozen shell to push liquid material all the way to the surface. Pluto, the world we decided was dead, has a heat source. And that internal warmth leads to the single most debated idea in this entire story. The possibility of a hidden ocean buried roughly 100 miles beneath the surface, kept liquid by the slow radioactive decay of elements inside Pluto's rocky core. The evidence is not a photograph, it is a pattern. Cracks and ridges across the surface line up in ways consistent with what you would expect from a subsurface layer of liquid water shifting slowly beneath the crust. The western lobe of the heart, Sputnik Planitia, sits directly above what appears to be a positive gravity anomaly, a spot where something denser than the surrounding ice is concentrated underneath. Liquid water, denser than the ice above it, fits the math. If that ocean genuinely exists, it has likely been there for billions of years. Dark, pressurized, fed only occasionally by hydrocarbons seeping downward through cracks in the ice above, sealed off completely from sunlight. One of the strangest possible environments in the entire solar system for the basic conditions life requires to exist without any direct connection to a star at all. We cannot confirm it. Not yet. No Pluto orbiter is funded. No lander is on the books. The journey alone takes the better part of a decade. The budget for outer solar system science has been shrinking for years. For now, Webb is the only working tool we have, quietly checking back in every few months when Pluto swings into its observable sky, adding another data point each time, and almost always making the overall picture stranger than it was before. Just weeks ago, in July 2025, a new preprint analysis of Webb data revealed an unidentified absorption signal at 5.11 micrometers in both Pluto and Saturn's moon Titan, a chemical fingerprint that does not match any known molecule in any published spectral database. Something is sitting on both worlds that scientists have never seen anywhere in the solar system or beyond. The research has not yet been peer-reviewed, but the signal is clear enough that multiple teams are now working to identify it. Here's what I want you to take away from all of this. Pluto is not a dead end. It never was. It is one well-studied example pulled from a population so vast we can barely count it. The Kuiper Belt, that enormous ring of icy debris beyond Neptune, contains hundreds of thousands of objects larger than 60 miles across and an estimated trillion comets. Beyond the Kuiper Belt, the theorized Oort cloud may hold another trillion icy bodies stretching a quarter of the way toward the nearest star. If Pluto is cooling its own sky, bleeding its atmosphere onto a companion moon, producing prebiotic organic chemistry as a matter of routine, and possibly hiding a liquid ocean beneath a shell of solid ice, there is no obvious reason to assume it is the only object out there doing anything like this. It is simply the one close enough and bright enough for our current instruments to read. The outer solar system is not empty, it is not dead. It is a graveyard so densely populated that we cannot count the bodies, and every single one of them is doing something. Quietly, slowly, on time scales that dwarf human history, the cold edge of our solar system is performing chemistry we are only now beginning to read, and we have barely started to look. If stories like this one, grounded in published research instead of exaggerated headlines, are what you come here for, subscribe right now and turn on notifications. Webb is still pointing back at Pluto every few months, and there is a real chance the next round of data adds another genuinely strange piece to this puzzle. Drop a comment with what surprised you most and share this with someone who needs to hear it because this story deserves a lot more attention than it is getting. Thanks for watching, and I will see you in the next one.